All right, so our objective for today, I can factor polynomials completely. Let's read it together. 1, 2, 3. I can factor polynomials completely. Now, we've been looking at polynomials, but we've been focusing on quadratic trinomials. Is that correct? Okay. But I wrote polynomials because we're not going to have just quadratic trinomials or anything with a quadratic. Now, we're going to have other things that involve calling them polynomials. That's why I included polynomials. However, we're still going to focus on quadratic trinomials. I just want to make sure that you remember that a quadratic trinomial has a highest degree of what? 2. Nothing higher. Are we there? Yeah. And when we factor these, we know how to factor them because I showed you a couple of techniques. Number 1, we open two parentheses. We use the power ranger, factor both, last 2 terms, yada, 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 right? However, yesterday I showed you a couple of patterns as to how to find a perfect square trinomial. Remember that? And I also showed you how to find a difference of squares when it's a binomial. Okay? So for today, we're going to extend a couple more steps. And let me just show you the steps. You don't need to copy this or the steps. You already have the steps. The only thing different from before to today is step 2. Check this out. Look at step 1. I already told you when we started factoring polynomials, I said, from now on, your BFF will be the GCF. Remember that? And why does that have to be? Because we need to identify the greatest common factor before we do anything else. Get used to it, please. Okay? Because today we finished chapter 8. We're close to getting into chapter 9, which is next week. And we're going to start getting into equations. So check this out. Look at step 2, though. Step 2. Check for patterns. What kind of patterns did we look at yesterday? Perfect square trinomials. Remember that? And also difference of squares. Remember that? Yes. So the only difference from before, my steps before till today, is we're going to be checking for patterns before we do anything else right after the GCF. Everybody with me? So with that said, copy this example down. Example number 1. And for this one, copy the text, please. And after this, we're not going to write for the other ones. We just have the information for this one. It says, tell whether each expression is completely factored. If not, factored. Once again, it says, tell whether each expression is completely factored. If not, factored. They give us the polynomial 5x cubed minus 10x squared minus 15. 5x cubed minus 10x squared minus 15. All right, here we go. Pens down, eyes up here. I'm going to go over this one just to make sure we got our steps down. Here we go. Number 1. Focus, please. We said the very first step for factoring anything, our BFF, was what? GCF. Let's check for a GCF. You're just paying attention first. Let's see. Is there a number that divides the first, second, and third term? Yes, it's 5. Second, is there a variable on each of the 3 terms? No. So the only GCF that I have is 5, and I'm going to simplify this. Let's see. 5x cubed divided by 5 is 1x cubed. Negative 10x squared divided by 5, that's negative 2x squared. Negative 15 divided by 5, that's negative 3. Are we there so far? So step 1 was GCF. Step 2, I said, let's check for patterns. What kind of patterns did we find out yesterday? The perfect trinomial and difference of squares. First of all, this is a trinomial, isn't it? In order for it to be a perfect square trinomial, this had to be a square and this had to be a square. Is this first term a square? No, it has a cubic. Therefore, it is not a perfect square. The other thing, is it a difference of squares? No, because it's not a binomial. It's only a difference of squares when it's a binomial. For those of you that maybe you didn't understand the homework looks something like this. Everybody look up. X squared minus 9. This is a difference of squares because it's difference, because it's subtracting. Squares because we can take the square root of the first and the square root of the last. Remember that? Since this does not look like this, it is not a difference of squares. So, what's left? Let's see. Could we use the Power Rangers? Let's see. What would be the next step if we had a quadratic? Oh, wait a minute. But it's not a quadratic trinomial. Who notices that? It's got a 3 there. It's not a quadratic trinomial. Therefore, we cannot use the next step. What was the next step? Open two parentheses. The Power Ranger. We cannot use this. Why? Because this is a what? An exponent of what? 3. And what were we looking at? Highest degree is 2. That's why this technique will not work with that. Therefore, since we cannot find a pattern and we cannot factor using our techniques, therefore we are done. You box this and you label this factored. Copy that, please. Okay, let's copy this next one, example number 2. For this next one, you don't have to copy the text, just copy the polynomial. Copy this. 7x cubed plus 28x squared plus 21x. 7x cubed plus 28x squared plus 21x. Let's do this one together. Here we go. Once again, step 1, GCF. What would be our GCF for each term? 7. Does each term have at least an x? Yes. So we factor out a 7x, and let's simplify this. Let's see. We're left with 7x cubed divided by 7x. We're left with x squared plus 28x squared divided by 7x. That's 4x. 21x divided by 7x plus 3. Okay? So, did we do step 1, GCF? Yes. Step 2, let's check for a pattern. Let's see if it has those patterns that we learned yesterday. Can we check the square root of the first term? Yes, it's x. How about the last term? No. Then we cannot find our factors using that pattern. Is that correct? Yes. Therefore, from there, do we have a quadratic trinomial here? Yes. Yes, so from here we open two parentheses. What is our next step? Factor the first term. What do we write? X and x. Open up your Power Rangers. Yes. All right, so those of you that continue, let's see. 1 times 3, that's 3. That's our product. The middle term is 4. What factors of 3 give us the sum of 4? 1 and 3. So we write x plus 1, x plus 3. So all we have to do is bring down what? Our friend, right? Here they come. There you go. You box all 3 factors and you write factored. Now it's completely factored. Okay, so let's make sure we got the pattern. Step 1, GCF. Step 2, we check to see if this is a difference of squares or a perfect square trinomial. If it's not, we use our factoring techniques to finish factoring, and don't forget to write your GCF. Everybody got it? All right? Okay, here we go. Copy this next one down. Example number 3. Example 3. Example 3, A. 3x squared, open parentheses, 6x minus 4, close parentheses. And for B, we got x squared plus 1 times x minus 5. Copy those, please. As soon as you're done, we'll do them together. All right, let's do A. Okay, according to what they give us, because they still want us to check if it's already completely factored, they're saying, by what it looks like, that this is a GCF. Is that correct? But let's double check. Is there anything else inside of the parentheses in this binomial that has a GCF? What would be the GCF? 2. We open up parentheses and simplify this. What is 6x divided by 2? 3x. What is negative 4 divided by 2? Negative 2. And what was the 3x squared doing? It was multiplying, wasn't it? So you bring that down as a multiplication, right? Because you're not going to leave your cool friend out of the loop, right? So 3x squared times 2, that's what? 6x squared. Bring down your binomial, 3x minus 2. Now it's completely factored. So you just write factored. So what happened? We had to check to see that the first step was done completely, the GCF. Everybody notice that? Now, we finished GCF. However, did we check for a pattern? We didn't. Didn't we skip it? Okay, let me go back just up to right here. Is this a binomial? Is it a difference? Let's see if it's a difference of squares. How do we know? By getting the square root of this. Can we get the square root of 3x? No, so then we're done up to right there. Anybody with me? Okay? Yes? All right, let's see. This one, it says they give us two binomials, this one and this one. Let's focus on this first one. What's the GCF for these two? 1, but 1 times that is that, right? Okay? And what did I say when it's 1? Don't worry about it, right? Look at this one. What's the GCF for this one? 1, so don't worry about it, right? However, this one is a difference. Let's check to see if it's a difference of squares. Can we take the square root of x? No, and this one either, so I think we're done. So this one, it's factored. I know the homework's going to be like probably super easy tonight because there's some of them that are already factored, so all you need to do is check. Okay? Do another one, number 4. Not a lot of work. Number 4, copy this one down, please. 4a and 4b. For 4a, they give us 5x squared times x minus 1. And for 4b, they give us 4x plus 4 times x plus 1. See if you can do those by yourself. I'll give you a little bit of time, and then I'll go over it. Go. Okay, let's see. A. So by the looks of it, they're telling us that this is the GCF. Is that correct? Okay, let's see. Let's look inside. Is there any other GCF? No. However, notice that this one has a subtract, so it's a difference. Let's check to see if it's a difference of squares. Can we take the square root of x? No, so then we're done. This one is done, and we just write factored. Yes, write factored, please. Okay, let's look at V. They're telling us that these are my two factors. However, let's check for GCF. Let's look at this one right here. Do you see any GCF for these two terms? Very good. 4. So therefore, what is 4x divided by 4? X plus 4 divided by 4? 1. Bring down the other factor. X plus 1. Uh-oh, what do you notice here? So we can rewrite this as 4 times x plus 1 squared. Bam. And that is factored. So once again, what is the one thing to remember to always check from the beginning? GCF. From there, you check patterns. From there, you move on to the next thing. So now let's see. If we were to check for patterns, these are binomials, but are they differences? No. So we're done. That's why we rewrite it there. Do another one. Number 5. Here we go. It says, factor 10x squared plus 48x plus 32. 10x squared plus 48x plus 32. Okay, let's do this one together. Here we go. Turn to your neighbor, let them know the GCF for this trinomial. Okay, 2. Is there any variable repeating in each term? Nope, so it's only 2, so let's simplify that. 10x squared divided by 2, that's 5x squared. plus 48x divided by 2, and 32 divided by 2, that's 16. Okay, so step 1, did we find the GCF? Step 2, let's check for a pattern. Do we have a trinomial? Yes. Let's check to see if it's a perfect square. Can we take the square root of the first term? No, because it's a 5 and it's not a perfect square number. So, do we know how to factor these kind of trinomials? Yes. What would be the next step? Open two parentheses. From there, Power Rangers. So there it is. We open the Power Rangers, and let's get our product. What is 5 times 16? 80. That's our product. And our middle term is 24. That's our sum. And factors of 80, if you don't see it, you write them out. 1 times 80, 2 times 40, 3 times nothing, 4 times 20, and it looks like I can stop there because it's what? 4 and 20. From there, check this out. This is where it's different. We rewrite our first term. What is our first term? 5x squared. Are we there? And instead of writing 24x, we're going to write 4x and 20x. So this is plus 4x plus 20x. Remember these? And what comes at the end? What's our last term? Plus 16. Now we can group them. We group the first two and the last two. And once again, GCF. Here it goes. What's our GCF for these two terms right here? 1x. And yeah, isn't x found on these two terms? And we're left with 5x plus what? Plus 4, because we took out the x, right? What's the GCF for these two terms? 4. So it's a plus 4. And what is 20x divided by 4? 5x. What is 16 divided by 4? 4. So let's see. What's the same here? And so you write it here, 5x plus 4. What's left over for this term? X. What's left over for this term? 4. So this is x plus 4. However, don't forget about the friends. Here they come. Can I come with you guys? Yes. There it is. And now it's completely factored. So do you notice that we're still doing the same thing that we've done? Now we are only checking for patterns just in case there is a perfect square or a difference of squares. Yes? Okay. Copy this one. Example number 6. Example number 6. Here it is. 8x to the 6, y to the second, minus 18x squared, y to the second. Okay? So once again, we're going to check to see if it's factored. If not, we're going to factor it completely. So here we go. Let's do it together. Once again, GCF. Let's see. What number divides this term and this term? Is it 2? 2. Okay, we got 2. What variable is found in both terms? X to the second. Do you see how both of them have at least an x to the second? What else? Y to the second. So there it is. So now let's simplify that. Let's see what we have left. 8 divided by 2, that's 4. X to the 6 divided by x to the second, we're left with x to the 4. When we divide, we're subtracting exponents. Remember that? And we already took out the y squared. There it is. So this is minus 18 divided by 2, that's 9. Did we take out already the x squared and the y squared? Yes, they're right here. So now check this out. Step 1, did we find the GCF? Yes. Step 2, let's check for patterns. This looks like it's a what? A difference of squares. Let's double check. Can we find the square root of the first term? What is it? 2x squared. Can we find the square root of the last term? Yes. If we can, then it is a difference of squares. So what are my factors? 2x squared plus 3 and 2x squared minus 3. Because it's a difference of squares. Is that correct? And don't forget about the friend, 2x squared y squared, and now it's completely factored. Right, factored. Okay, number 7. Let's continue. Okay, copy this one. 4x cubed plus 16x squared plus 16x. See if you can do this one by yourself. I'll let you go and do this one. Go for it. Go through all your steps, please. Okay, don't forget. Step 1, GCS. What number divides each term? 4. Oh, sorry. 4. What other thing does each term have? An x. Now let's simplify this. 4 divided by 4 is 1, and x cubed divided by x is x squared, or 1x squared. 16x squared divided by 4x, 4x, plus 16x divided by 4x, that's 4. So now check this out. We already got the GCF, didn't we? Let's check for a pattern. Can we take the square root of this one? Yes. How about the square root of this one? Yes. Let's see. What is x times 2? No, x times 2. 2x. Double that? Does that give us a middle term? So this is a perfect square. So check this out. So if it's a perfect square, we write x plus 2 times x plus 2. Bring down the GCF. How can we rewrite this? 4x times x plus 2 squared. And now it's factored. Now check this out. On this one, you can do Power Rangers, and you get the same answer. So check this out. If you open 2 parentheses from here, what is the first step? Factor this one, x and x. Are we there? The Power Rangers, you would go 4 and 4. What factors of 4 add up to 4? 2 and 2, and that's how we get these 2. Everybody see how it still works? Yes. Let's do another one. Number 8. Okay, copy that one. Number 8. 2x squared y minus 2y cubed. 2x squared y minus 2y cubed. Okay, let's do this one together, just to make sure that we get all the steps. Here it goes. Step 1, G, C, F. What divides here? That divides here. 2. Does each term have an x? No. Does each term have a y? Yeah, so you write y, so my GCF is 2y. Let's find out what we have left. 2 divided by 2 is 1. We're left with what? X squared, okay? Because we took out the y. Negative 2 divided by 2. Negative y squared, because we took out one y, didn't we? All right, so we already found our GCF. Let's look for a pattern. Is this a binomial? Is it a difference? Yes, let's see if this one's if we can get the square root of these 2 terms. What is the square root of x squared? What is the square root of y squared? Y. Since we were able to find the square root and it's a difference, therefore, what are our factors? X plus y times x minus y, and you bring down the GCF, which is 2y, and we're done. Factored. Everybody got it? So once again, what are we doing? We're doing everything that we saw for this chapter 8 on factoring polynomials all in one. Is everybody with me? The only thing, do not forget to always check for GCF to see if it's completely factored. After that, check your patterns. Is it a perfect square or is it a difference of squares? Then after that, you know what to do with factoring using the Power Rangers or factoring by opening parentheses and such, right? Yes. So, homework. Homework is found on page what? 525, numbers 1 through 47 odd only. All right? Turn in your homework on your way out, guys. And enjoy your homework. I'll see you guys tomorrow.